what's different about organizations like Amazon or Google or Netflix? It's not that they are some kind of magic people. It's just that they are working more effectively.
Hello, dear subscribers of 0800 DevOps. Today, I'm talking to Dave Farley, a pioneer of continuous delivery. This year marks 10 years since he wrote a book called also Continuous Delivery, together with Jez Humble, and this book revolutionized the way many people think about the concept. I know for sure that it did that for me. Dave is truly a pioneer in software development. 30 years ago, he was working on loosely coupled and message-based systems that were the introduction to modern SOA and microservice architecture the way we know it today. So, Dave, thank you for this conversation and your time today. And please tell us, what do you focus on and how do you help organizations these days?
First, it's a pleasure and thank you for inviting me. These days, I work as an independent consultant. Mostly what that means is that I go to work in other people's organizations and try and help them improve their software engineering practices. Most of my clients tend to be larger companies, probably because my fees are reasonably high. But mostly they're kind of bigger organizations, and so dealing with software development at large scale and in complicated scenarios with maybe hardware as part of the problem and all that kind of thing. So I spend quite a lot of time doing that. My consultancy is very broad ranging, and I'm a software developer by profession. So that's what I spent my time doing, building systems. And so I'm more than happy to talk about code and design and architecture and test-driven development and those kinds of things. But also I was a technical leader in the latter parts of my career, so I'm often also helping with sort of broader organizational strategies and how engineering fits into the business and how software engineering fits into the business and all that kind of stuff as well. That's mostly what I do.
It's been now not almost, but it's been 10 years since Continuous Delivery book has been published for the first time. What has changed since then? Since the day it was first published, since the day you wrote it?
It's a good question. There's lots of things that have changed for me as a result of writing the book. It kind of changed the direction of my career, I guess, as a result of that. In terms of the industry, I think that there are two. I'm schizophrenic, so there's part of me that thinks that not very much has changed, and there's another part that thinks that there's a lot of change. So let's talk about the stuff that has changed a lot first, because that's what we think of. That's the way in which we're used to thinking about our industry. So the huge change, I think, the huge move has been the cloud. At the point at which Jez and I wrote the Continuous Delivery book, the cloud was a very new thing and nobody really knew yet what it was. We were doing some cloudy things with the early versions of the cloud on some of the systems that we were working on at the time, but it wasn't yet a big enough thing to include really significantly in the book. So when we talked about ideas, I think with hindsight, you could say that we were talking about ideas a bit like containers and a little bit like, but in the context of virtual machines and so on. And I use the term, I think, images when I was talking about trying to copy those versions. So there's that sort of stuff. The ideas were kind of nascent there. And I think that the cloud is probably the most significant change over that period of time. Hubristically, I would also say that continuous delivery is one of the significant changes, but I think the cloud is the most significant one in terms of technology over that period of time, and that's kind of raised the level of abstraction and democratized access to some difficult jobs. So the operations of systems and it's kind of commoditized a lot of that stuff. We no longer have to worry about the wiring of our servers or how much disk space we've got left. We can leave that for Microsoft, Amazon, or Google to worry about instead of us. So that was a big change. The things that I think haven't changed as much, I think there's a degree to which our industry's a bit of a fashion industry, and we like the idea of changing a lot. And so, you could point to, the growth of JavaScript as a programming language, or that kind of thing. There's part of me though that I think fundamentally programming hasn't changed. I'm in the middle of I'm writing another book at the moment about software engineering, and one of the exercises that I'm doing for a personal reason, just to try it out, is that I'm writing a very simple application, sort of a simple CRUD web application, and I'm doing it in the latest version of AngularJS, and I'm doing it using technologies that were available in 1996. And so far, I've not finished with the exercise yet, but so far, I think it's about somewhere between a quarter and a third of the code in the 1996 version. And that's not counting the libraries, that's just the code that I've had to write. So I don't think that we've made as much progress as we think that we have in terms of the tools and the technologies at our disposal in some areas. I think that some things have certainly moved and others that have not. In terms of development approach, 10 years ago was an interesting time. So 20 years ago, when I first started on the road that took me to being one of the people that came up with the idea of continuous delivery, I think that the absolute norm, if you'd done a survey of big companies and asked how they built software, they would have all said waterfall because they thought that was the right answer. Now, if you did 10 years ago, I'm not quite sure where we were 10 years ago, but certainly now, if you did that survey, the answer would be agile. And that was a huge move. When I started working for ThoughtWorks on early agile projects, we had to do it under the radar. We had to do it by stealth and pretend that we weren't doing agile things because everybody would think that we were crazy. Now they'd want they'd want those services. So that's definitely moved on. These days, I think we're kind of approaching, in some ways, not in any real ways that matter, but I think that in terms of the mindset, the zeitgeist, we're starting to approach kind of post-agile thinking, and people are looking for the next thing. And at the moment, I think that the next thing that people aspire to, in the way that they aspire to agile thinking, is continuous delivery. And I think that's kind of interesting, because I think they're for kind of common reasons. I think agile was a necessary and important step. I am a card-carrying agilista. I'm a true believer in the agile principles. I think that most of what we practice in the industry isn't very agile. We kind of play lip service to it too much. But I think that the principles are correct. And I think that what agile did is it moved the game on from a very bad fit, which was trying to apply kind of production line thinking to software development. We don't have production problems. We don't have those sorts of production line problems. We have problems in terms of design and creativity and exploration. So it's completely, those sorts of production line principles like waterfall development are completely the wrong fit for software development. Agile threw that out, which was great, because it started, my favorite soundbite for agile is inspect and adapt. So it started us thinking instead in terms of how we can learn and how we can kind of discover new things and how we can iterate quickly to be able to facilitate that learning. And I think that was absolutely centrally an important step to take for us as an industry to be able to learn. Continuous delivery, I think, is absolutely a second generation advanced agile practice. But I think that what it is it takes that idea of agile, which I think is in part characterized by being a craft-based approach to some extent, to adding on engineering. So you still want the iteration, you still want the learning, you still want the flexibility, but now we're going to be a bit more accurate with measurement. We're going to be thinking a little bit more carefully about what it takes to control the variables so that we can run little experiments in the form of automated tests, hundreds of thousands or millions of times, and get fast feedback and learn and move forward on the basis of evidence. So I think that's where we are in terms of how things have moved on. I think that we are making progress, but it takes a long time for these sorts of ideas to play out. Agile was certainly not wrong. I think waterfall was wrong. I think it was a misapplication, and I think some people have known that since the 60s. If you read The Mythical Man Month by Fred Brooks, published in 1970, it's all about the kinds of problems that we were bemoaning in the early 2000s about big projects and working more iteratively. They used to call it spiral development rather than iterative development in the olden days and stuff like this. So it's definitely our industry has always been and still is, homogeneous. It's not homogeneous, heterogeneous. It's all different. It's people have different experiences. So I think now that we know better what really works than we have ever known. I think that we have stronger models, and I certainly feel that we can be more, to some extent, more prescriptive. I think we can say now with more confidence, don't do that because it doesn't work, which we've been really bad at doing historically as an industry. But I think now we can say some of those things, we can rule some things out, which is good. And there's a whole bunch of other things, which is, that we now know, properties that we can add in that really allow us to do a good job of software development.
Yeah, I really like this idea of putting continuous delivery beyond Agile, because what I see is a lot of organizations embracing agility in terms of collaboration, iterations, but down there where the rubber meets the road, when you need to actually deliver something, they are lacking a lot of skills, capabilities, and basically the idea, why are we doing all of this? So what is the goal? Where is the customer? There is no customer in sight yet.
Yeah.
And continuous delivery kind of gives us this focus. Why are we doing all of this? All these practices and agility are basically prerequisites for delivering something as fast as possible to the customer.
Yes, which is what the Agile Manifesto said. We got, when Jez and I wrote our book, we got the title from the Agile Manifesto. The first principle says our highest priority is the
continuous delivery of
the continuous delivery of valuable software, the early and continuous delivery of valuable software to our users. That's where we stole the phrase from. So it's absolutely in line. But I agree with you. I think that continuous delivery. I think of continuous delivery, as I said, as a second generation agile approach, and actually it's kind of second generation extreme programming. So to me, the most important agile discipline for me was extreme programming. I think that was way more important than Scrum, although Scrum was the one that won the mind share. So Scrum's a project management discipline, and it's useful in that context, but it says nothing at all about how to write code or develop systems. It just says how to organize people. And that's useful to know, but you also need to be able to write code and develop systems.
Yeah, but we somehow forgot that part.
Yeah, it did. So I think of continuous delivery as kind of the offspring of extreme programming, but applying, just taking the kind of engineering thinking that was in extreme programming and taking that a little bit further.
Yeah. But Dave, we are talking a lot about continuous delivery. For people maybe not familiar with the concept, could you define in a couple of sentences what continuous delivery really is about?
Sure. My favorite kind of soundbite for continuous delivery is that we are trying to work in a way so that our software is always permanently in a releasable state. And as soon as we make some mistake that stops it being releasable, we correct that mistake as quickly as we can. So we maintain that software in a releasable state. If you think about that for a minute and think about what that entails, it means that we've got to have really, really fast, efficient feedback. We need to get, we need to be able to learn really quickly when we've made a mistake. So we're going to optimize. So another soundbite, another way of thinking about this. We're going to go from idea to working software in the hands of users and make that process as fast and efficient as we possibly can. And keeping our software in a releasable state is one of the tricks that we use to achieve that end. Now, in order to achieve that, it takes all sorts of changes in the way in which we behave. To be able to work, so your software is always in a releasable state, has a profound implications for the way in which we work, as it turns out. If you want to be world class at this kind of approach, it means dropping all sorts of ideas that traditionally we would have held. So you can't afford to spend a lot, weeks in analysis up front, or doing lots of compliance after the fact, or having manual user acceptance testing, or all those sorts of things, because the feedback loop's too slow. I want to find out within the same working day whether my software is fast enough, scalable enough, resilient enough, compliant, safe enough to release into production. So I'm going to build supporting technology to give me fast enough feedback so that I can learn that lesson, usually, ideally, in under an hour. So in under an hour, I'm going to be able to go from commit to a releasable outcome, whatever it takes for me to achieve releasability. And that's what I'm trying to achieve. I'm going to optimize for that. And that, as I say, it changes the way that we think about organizing software development teams. It changes the way. It changes the way that we program. It changes the way that we design things. We're going to instead of thinking hard and coming up with a design and then implementing that design, we're going to be more evolutionary in the way in which we approach our design. I'm going to use test-driven development to evolve my design step by step, tiny step by tiny step, so that it's always working, it's always tested, it's always releasable.
Yeah, it's a very profound way in which you actually behave differently while trying to achieve continuous delivery. Somehow all those best practices that you hear about and that you know that you need to apply, but somehow, maybe I don't need them. Somehow now you actually need them.
Yes. And that's, I think that's one of the huge, practically, from my point of view as a consultant, trying to help people improve their engineering discipline in their organizations. Continuous delivery is the most fantastic tool. Even if those companies don't achieve full continuous delivery by the end, it's a fantastic tool to improve their disciplines. If you think about for a moment what it takes to achieve what we've just talked about, in under an hour, I'm going to get to a point where any change that I make is releasable into production. So what would that take? If I want to start from somewhere where I'm releasing software every 6 months, every 3 months, whatever it is, if I start from there, it's going to take me a long time. It's hard work. It's a very difficult transition. But I'm going to start optimizing to reduce that cycle, to speed that up, to make it more and more and more efficient over time. And if you do that, if you start working kind of experimentally, trying different ideas out and seeing what works and seeing what doesn't, and you just focus on reducing that cycle time over a period of months or even years, then I think that you drive out all of Agile principles, all of DevOps principles, all of lean principles, and all of continuous delivery principles. You can't go from commit to releasable thing if your team's too big, because the communication overhead will slow you down too much. You can't go from commit to releasable outcome in under an hour if you're dependent on lots of other teams. You need these teams to be able to work fast and efficiently and get feedback quickly. For that, you need high levels of automation. You need automated tests, automated configuration management, infrastructure as code, automated deployment. You need collaborative working. You need designs that are testable. You need designs that are modular and flexible and easy to test. All those sorts of things. You need feedback from production. You need good relationships between developers and operators, and developers and the business, and QA and operators, and everybody needs to be collaborative. So you need these cross-functional teams. Nearly every aspect that you think of in terms of all of those, agile, lean, DevOps, continuous delivery, nearly every one of those, you can kind of hook onto this need for speed. If you drive for this speed, it will highlight those areas where you are not doing as good a job as you could be doing, and then you can work on improving those things.
Yeah.
So it's a fantastic tool to drive change in an organization. And there is some data from the State of DevOps report and the fantastic Accelerate book that backs this up, saying you can use the technical principles to effect organizational change, which changes not just the technicalities, but also the development culture and ultimately the organizational culture for the businesses that you operate in.
Yeah.
Which is a big deal.
Maybe just to drive the point even further, someone might ask, yeah, but why do I want to have this? I mean, why do I want to have something releasable in an hour? I am living quite decently now with releasing something weekly or monthly or quarterly. Yeah. What is the benefit for me in releasing in an hour?
So I think that there are two principal benefits of this speed. And a decent way to think about these is first to talk about the difference between continuous delivery and continuous deployment. So continuous delivery is working so your software is always in a releasable state, as we've already discussed. Continuous deployment is if all of this evaluation worked, you just push the change out into production. Now, simplistically, those give you two different things. Working so your software is always in a releasable state is a great thing for the quality of your software, even if you only release once every 6 months. You're going to build a better outcome because you're getting development feedback to release a releasable outcome. So every hour I'm going to know, yes, that change that I made is good. It works. It does all of the things. It didn't break anything. It's scalable enough. It's resilient enough, blah, 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 blah. And as a developer, if I can get that kind of feedback, I'm going to be able to do a better job. But if I am releasing only once every 6 months on that basis, then I might be building a really high quality system that nobody's interested in or nobody wants. So going out into production frequently gives you a different benefit. It gives you opportunities to carry out, to learn from whether your users and customers actually value the things that you're building. And I saw a great a great bit of data once. It's from a few years ago, and the scenario will explain why. There was this team, and they got fantastic statistics. They got 8 times the average team's velocity, and they got these great numbers on the quality of all this stuff. But it was MySpace. So it wasn't software that anybody wanted. Well, they were doing all this great stuff, working really fast, doing high quality work for the wrong things. So you need also to be, software development and product development is about learning. One of my things is one of the reasons why I believe that continuous delivery is both important and will be long lasting as an idea, is that I believe that continuous delivery is deeply, profoundly the application of scientific principles to solving software problems in software. It's absolutely grounded in the idea of experimentation, controlling the variables and gathering feedback and learning from those and iterating and refining our understanding and deepening our understanding. It's absolutely foundationally grounded in those principles. And that's just as true of designing your products as it is writing your code. So applying this approach, first, it gives you engineering discipline that allows you to build a higher quality software more quickly and more efficiently. So, and there's data to back all of these things that I'm saying. There is data. Go and read the Accelerate book or look at the State of DevOps reports. We can build better software faster when we do this. So that's a commercial impact in its own right. Then, if we take advantage of that, if we release more frequently into production, That then gives us the opportunities as a business, as an organization, to see whether our products are good products and evaluate whether our products actually land with our users and refine our learning from that, and do that all the time. Amazon released change into production once every 11.6 seconds. That gives them millions of opportunities to learn. It's a fantastic resource to be able to carry out experiments and to figure out what works and what doesn't work. It stops us having to be brilliant and think, I'm going to have the greatest idea ever and predict the future. Instead, I can have some half-assed idea, put it out into production and find out how to improve it based on feedback from my customers and users. And so I think it brings different kinds of value. From a personal point of view, just purely selfish point of view as a software developer, it's also the most fun way of working that I've ever found, because I can focus on the stuff that I genuinely love about software development, which is the creative part. It's the part of thinking of a problem and solving that problem. And I automate all the grungy, boring bits, and they just happen. And I can focus on the design and the solving of problems, and which is the bit that I find interesting.
Yeah, this is something that really kills the creativity in people doing the same stuff all over again. That's right. Yeah. Automate everything and let the scripts take care of it.
So the data says that if you compare organizations that kind of practice continuous delivery and against those that don't, it says that we can create better software faster. We can have orders of magnitude fewer bugs in production than otherwise. That people that work in those organizations have more fun. Microsoft did a survey of their employees. Bing adopted continuous delivery a few years ago, the Bing team. They did a before and after survey so that they got people to evaluate their work-life balance. Before continuous delivery, the Bing team reported a work-life balance satisfaction survey of 38%. And afterwards, they reported a work-life balance of, I can't remember, it's 72 or 76%, but it was in the 70s. So people, you can build better software faster, you can have fewer defects, it's higher quality, people enjoy it more. And the bottom line is that if you look at the organizations that employ continuous delivery, they make more money than organizations that don't. There are economic impacts of doing this. So if you want your organization to be successful commercially, continuous delivery is the right thing to do. So all of those things added together, it's kind of too big to get your head around, really. But I think this goes back to what I was saying earlier about, I think of this as a genuine engineering discipline. If that were true, then all of the things that I've just said is what you'd predict. Engineering in other disciplines is the stuff that works. The difference between an engineered solution to something and a craft-built or home-built solution is quality and productivity and being able to do that stuff for a price. You go and look at the difference in price between having hand-stitched leather seats in your Ferrari versus mass-produced thing that's in reality the mass-produced thing is going to be higher quality as well, because it'll be more precise, it will be with more precision. It's just that we have an emotional attachment to hand-stitched leather seats. But so engineering ups the quality, improves the productivity, and makes it all more economic. And so you'd expect to see the kinds of results that I think that we do see, that we measurably do see when we apply continuous delivery in organizations.
Yeah. Sometimes it's even useful to look at the counterexamples of organizations that didn't have continuous delivery. Like, for example, Nokia.
Yes.
Ended up very sadly due to the fact that it took them a couple of weeks to deliver Symbian release.
Yes.
So, yeah, it's pretty clear what can happen if you don't put such a process in place. Yes,
and I definitely think that's the case. I think ultimately, if I were right, just a thought experiment, if I was correct, and this is an engineering discipline, and all the things that I said were accurate in terms of the predictions, then what we'd expect to see is that this provides a definite competitive advantage to organizations. And I think that we do see that. And as I said, organizations make more money, but it means that if you are not practicing continuous delivery, at some point or another, a competitor is going to come along who is, in Nokia's case, a bunch of other, more effective mobile phone manufacturers.
Yeah.
And when they do, they're going to kick your ass in the market. They're going to be able to, they're going to be able to beat you in the marketplace because, that's how this stuff works.
Yeah.
So many of the biggest organizations in the world are really very, very, very seriously adopting continuous delivery and working very hard to adapt to working that way. And if you think about organizations in in software that we think of as examples of doing a good job, nearly all of them that I can think of are practicing some form of continuous delivery as part of their approach.
Yeah.
Or are making the move towards it, certainly.
I feel somehow that in a lot of organizations, continuous delivery is still concerned as a technical improvement and technical solution to technical problems, and not that much focus is put on the business side. All these benefits that you just stated from the business point of view. So fast experimentation, quick feedback loop, testing hypothesis, quick check whether this feature is actually accepted by the customers or not. This is something that is basically not mentioned in these conversations. And somehow I feel that this is the message that should also be put out loud to the business side of the organizations.
I agree with you. I think that this is such an advantage that it shouldn't be constrained as just a technical practice or thought of in that way, because the real impact is on the business. I mean, I'm a techie nerd, so I value it from that point of view. But the real impact is the commercial, the impact that it has on the organizations that practice. Software is important in the world. It's certainly the thing at the moment that is driving our modern high-tech society. The advancement and the commercial opportunities are largely driven through software, ultimately, in one way or another. So this is a big deal. And so if you could make even a small percentage difference, let's just be one specific. There's data that says, there's information that says that data centers represent 1% of carbon emissions. So if we could make software development as an approach more efficient, more effective, that would reduce that 1% of carbon output. It would have an impact on the planet. It would improve the quality of the stuff that we're producing. It would, So these things are not small ideas. These are not narrowly focused on, oh yeah, I automated the deployment. This is a bigger deal than that. And when you, just from a commercial point of view, when you start to think about, what's different about organizations like Amazon or Google or Netflix, it's not that they are some kind of magic people. It's just that they are working more effectively. And they're working more effectively because they got these better processes. And it's not just the technologists that are working more effectively. The whole businesses are. Amazon is remarkably unusual in that if Amazon doubles in size, it more than doubles in profitability. Normally there's some interesting network, there's some deep maths behind some of this, and there's some interesting network effects that were explored by an organization called the Santa Fe Institute. Normally if you double an organization in size, its profitability will go up by 85%. Amazon, if you double them in size, their profitability goes up by 115%. That's unusual, and in part it's because of this kind of, I would think of it as a more scientifically irrational approach to the way in which the business is organized, as well as the technology. And that's flowed on from some of this kind of technical thinking, but it's all part of the same thing. I think one of the interesting things, if being slightly philosophical for a minute, if you'll forgive me, is that I think that what we software people have done is we started, if you think about the history of what we did, we started out just automating the processes that were already in place in organizations. And that was kind of one part of the software revolution. And then more recently, mostly only in this century, so this really wasn't happening so much at the end of the 20th century, we've started doing much more innovative things. We've now started revolutionizing businesses based on software. And so you get the concepts like digital disruption and those sorts of ideas at play. And you can think of Uber and my mind's just gone blank. You can think of all those sort of I was going to say the company that sells apartment places in other people.
Yeah,
Airbnb. Thank you. Yeah. So Uber, Airbnb. Yeah. So those are completely different business ideas based on what you can do when you democratize, access to information through software and the internet. And so it's a tool that's leveraging businesses. Most of the traditional businesses that I'm aware of, certainly in sectors like banking and finance, they're scared to death that the next big disruption will be in their industry and they're going to be hit. So they're looking to how to lever up. So what we've done is that we've, for a long time, business for 150 years or so, largely business approaches to business organization was fairly stable. We've been disrupting that. We've been changing that. If you go into a modern high-tech business, it doesn't look like a traditional business. It's, Amazon doesn't look like, your traditional kind of organization. They are organized differently, they are managed differently, they work differently. And if you went in there, you probably wouldn't be able to tell the difference between a software developer and a marketing person or a business person. They're working together collaboratively, intimately, interlinked, doing creative things. And I think we, to a large extent, through technology, have been driving that kind of change in business as well. And so for those businesses that want to be able to keep up, be competitive, because we're still only just starting with our software revolution. So in the next round, if people want to be able to keep up and be able to do this, then ideas like continuous delivery are table stakes. That's just the starting point.
Yeah. It basically becomes a prerequisite for any digital innovation initiative in the organization. Digital initiative culture, innovation culture.
Yeah, and you and I were having a conversation a week or so ago about economies of speed. So one of my friends, Gregor Hope, came up with this phrase, economies of speed. In the genuinely digitally disruptive sphere, the speed of being able to iterate really fast and have ideas really quickly and try them out is a competitive advantage. And if you think about those sorts of organizations that we've been talking about, Tesla, Airbnb, Google, Amazon, Netflix, they are where they are and being successful in the way that they are because they are able to move really, really, really quickly and try out ideas and discard the bad ones and go with the good ones. So being more experimental in terms of business. And I think we've done that. I think the software industry has given that capability to business.
Yeah, we just need to change some of those cost center mindset where people actually look how to cut costs instead of use software as a competitive advantage and move it to a profit center. Because a lot of organizations do think in this way only when some external hard-pressed deadlines come, but they will never use this. They will never prioritize speed over cost if they were pressed by any deadlines, external deadlines.
And that's I keep talking about science and kind of applying that kind of rational thinking. If you start looking at the numbers, even that's kind of questionable because what we're talking about here is the most efficient way that we know to develop software. So by doing all of this automation and spending a lot of time and effort on things like automated testing, you don't go slower because of that, you go faster. because you get the payback. So I was involved in building a complex, sophisticated trading system, a financial exchange. We were in production for 13 months and 5 days before the first defect was noticed by a user. That meant we didn't have meetings to do lots of bug triage. Well, we did. We had a few because we found some bugs, but we didn't have long meetings and long lists of bugs to deal with. We had a tiny fraction of a % of the bugs that you would normally expect in a system of that size and complexity, which meant that we didn't spend lots of time working about those sorts of things. We were spending time thinking about new stuff instead. And so, you know, that's the payoff that everybody misses. So I think if I was a software, you know, if I was working as a software developer these days and my employer was saying we must go as fast as possible, then I'd be doing test-driven development, continuous integration, continuous delivery, because that's the way of going as fast as possible.
Yeah, it's one of those maybe paradoxes that it's hard to understand.
It is.
See the numbers, like you were mentioning, accelerate, and how could it even be possible to be both fast and stable at the same time? So
yes,
yeah, that can be. If you want to be stable, you have to go slow, or other way around. But it's not like that.
Yes, indeed, and there's quite a lot of this stuff that's kind of counterintuitive, which is fair. You know, I think that as you get to, I'm a science nerd. One of my hobbies is reading about physics. As you get to the boundaries of physics, it gets weirder and weirder and weirder and less obvious. Kind of obviously, because if it was obvious, we would have thought about it before. And I think it's kind of similar. So it's not obvious that working really quickly in small changes is safer. But as soon as you find out that it is, it's kind of obvious why. So if I make a tiny change and then can submit that change and get feedback in under an hour that the change is good and safe to go into production, just think for a moment about the nature of that change. It's going to be tiny. If I work that way all of the time, that change is going to be tiny. It's going to be so simple that it's going to be really hard for me to screw it up. Even at my advanced years and my flaky coding, I'm less likely to screw it up because it's going to be small and simple. I'm going to be able to reason about it. I'm going to be able to understand it. I'm going to be able to test it properly. I'm going to be able to back it out. If it does go wrong, I'm going to be able to back it out really easily. And so this is actually a safer way to write software. The places where nasty, horrible defects lurk is in over-complex software. So if we work in these tiny little steps, it starts to encourage us to write smaller, simpler bits of software that all work together. And that's better. That's good. That's a good thing.
Yeah, I fully agree. I did my fair share of coding, and I remember once in 2005, we were also doing a software for one of the banks, and long nights merging hundreds of files and trying to build something releasable just to figure out in the morning that it's missing something. And so it's totally wrong way of approaching the problem.
Yeah. So part of my book that I'm working on at the moment, hopefully available for all good book publishers next year. But the theme of the book is what are the kind of durable principles that kind of we could think of as engineering discipline for software. And I think that they fall into two groups. I think that the mistake that we've made, as I mentioned before, is thinking of software as a production problem. We don't have a production problem. Software is unusual in that production for us is almost free. We can write a system, however big or complex it is, we can clone that system by just copying the bytes at the push of a button. So production is not our issue. That's unusual in human experience, but it's true of us. So our problem is always about the learning and discovery and exploration of how to solve the problem in front of us. So we should become world experts at problem solving, learning and discovery. And the way that you do that is you apply science, because science is the way that you solve those problems. So you need to take seriously ideas like iteration, feedback, experiment, empirical discovery, those sorts of ideas. And then there's another class of problems, which is about what we've just been talking about. How do we build systems that are bigger and more complicated than can fit into one person's head? So how do we compartmentalize systems so that they can safely fit inside our heads and we can work on them? And that's about ideas like modularity, cohesion, separation of concerns, abstraction, and coupling. And so we want to be able to think about those seriously. And I think that you could build an engineering discipline just on those principles. I think that, if you use that kind of thinking as starting points, if you built a system, I don't care what language it is, I don't care what technology it is, I don't care what framework you used. If you built a system that was modular, appropriately coupled, fairly loosely coupled in lots of places, had great separation of concerns, was cohesive, that is going to be better than any system that doesn't have those properties.
Definitely.
Objectively, you'd be able to measure the ways in which it was better. It'd be more composable, more flexible, more usable, more easier to work on. So those are the kinds of principles that I think that we should be valuing much more highly than we do. I confess that I get a little bit, in my grumpy old man mode, I get a little bit tired of sort of language wars, and I don't think the language matters very much as those principles. And yet we almost never talk about those sorts of principles.
Yeah, I always remember one of the conferences where Kelsey Hightower wrote a service in Fortran and ran it in a Kubernetes and solved business problems. So yeah, it doesn't really matter which programming language you use.
No.
And I'm sure you are sick and tired of always coming back to those same old principles, because 30, 40 years ago, we were talking about the same stuff. And somehow we always reinvent the same.
Yeah. And I'm pretty sure if human beings are still writing software in 100 years' time, I'm absolutely certain that those principles will still be just as true. Yeah. Well, even if they're not, even if it's the robots that are writing the software by then, they'll still need the same principles, because even robots will have some kind of limited capacity on their ability to hold information. It'll be bigger than ours, but it'll be some kind of, it'll be finite.
Yeah. Dave, in your experience working with different organizations recently, what is the state of continuous delivery today? Is it widely accepted in organizations, or do we as an industry still have a lot more to do?
I like all of us, I am the victim of my own Google filter bubble. So I see the world through continuous delivery styled glasses to some degree. From my perspective, it looks to me as though continuous delivery as an idea has crossed the chasm. It's now seen as what everybody wants, is the way that I see the work, is what I perceive. In practice, there's a lot more it's where it's spoken about rather than practiced, rather like Agile was. There's lots of people that say we're doing continuous delivery when they mean that somewhere or other in their organization they're running Jenkins. That's not the same thing, not by a very long stretch. So continuous delivery is about working so your software is always in a releasable state. Can you make a commit and get to something where there's no more work to do, and you can release it into production within the same working day, but ideally within an hour? If you can do that, then I would say that you're practicing continuous delivery. If you can't do that, you're not there yet. And there are many fewer organizations that are in that state. There are lots and lots of organizations that are on the journey, though. And as we said, there's huge value in making that journey. One of the so continuous delivery is not something you can buy a tool to adopt. So you can't buy Jenkins or Bamboo or TeamCity or Circle CI or whatever. That's not going to do it on its own. It's about the discipline that you apply and the way that you think about making change and the way that you approach testing and all of those things as well. So I think it's definitely, as an idea, it's kind of crossed the chasm, and I'm very pleased. I think that nearly, I think that there are a few software vendors in the build space that don't have some kind of continuous delivery products in some shape or form these days. That simply wasn't true 10 years ago. So that's definitely moved on. And I think that the sophistication is going up as we go through some of those things. I think there are some missing pieces. There's some stuff that I've done in the past mostly for larger systems, to be fair, that I don't see yet as kind of in the marketplace. So things like being able to manage a very big build grid and, you know, coordinate the work and allocate work and all that kind of stuff. I'm seeing less of that sort of thing, and to some extent that's, you know, that's managed by cloud resources, but still there are some tools that are missing. But I think that the sophistication is coming along. But I think there are also many people. It's at the moment, it's still at that stage where it's seen to be cool to be practicing continuous delivery. So it's an aspirational statement to say my company is practicing continuous delivery. And I think there's a few people that are in that kind of space.
Yeah. And for the people understanding that this is their aspiration and they understand they are on the beginning of their journey, what would you say are the best first steps to start introducing continuous delivery in the organization?
I do this a lot with organizations, helping them through those early steps. And it does vary. It varies quite a lot depending on the nature of the organization and what the barriers are. The biggest difference is probably team size, or the organization size, I suppose. If you're a small team working independently, starting from scratch, it's relatively easy to get started with continuous delivery. So the way that I would recommend is sort of start out with kind of a walking skeleton and build your continuous delivery infrastructure around that. So start off your initial steps in trying to build a deployment pipeline and start doing that kind of thing. So come up with an example story that's kind of a thin architectural slither of your system. Write some tests for that, do test-driven development, write some tests for that, then do the hosting of those tests in whatever technology makes sense for you, and then generate something that's deployable and deploy it, and write an acceptance test and write some tests against that, and run those tests. Just one test maybe, but set up the infrastructure. So you use the example story feature to force you to build an initial very, very simple deployment pipeline, and go all the way to even if you're not going to you're probably not going to release this into production, but but deploy it at the end into something that is notionally a production environment. So it forces you to think about the configuration management and the deployment of the thing. You can do that usually in a week or two. You can get that up and running, and then the next story, you have all of the infrastructure in place. So all you got to do is write the tests, and it's going to magically happen. And from then on, it's going to get easier and easier and easier to carry on working that way. So that's the easiest way to start. I do have a video on my YouTube channel that describes that process in a bit more detail. If anybody's interested,
we'll put links in the comments.
Great, thank you very much. So it goes through that. To get into the continuous delivery culture is a bit more involved. It requires more of this kind of engineering style thinking, and that means challenging some mindsets, and that's probably going to, I'm trying to avoid sounding like a salesman. It's going to involve you needing some help from somebody probably that's going to help guide you. That's the easiest way to do this. In organizations, so you can start doing some of that stuff. If you've got existing code, so start just looking at how efficient your process is. Do something like a value stream analysis. Look at your cycle time, figure out how long it takes you to go from idea to valuable software in the hands of users, and try and put some times on each of the steps. And then start to figure out, so what could I do to shorten that time? Or, is there any of this waste in this that I could eliminate? And start doing that kind of thing. And often it's not to do with software or technology. Often it's just, okay, we put this piece of paper in somebody's in tray, and then 3 weeks later they pick it up and they do something. Try and eliminate all of those kinds of things. Just make the whole process as efficient as you can, and think about it holistically, and optimize that kind of stuff. That starts you talking to other people. It gets you involved with talking to operations people in terms of the, starting to think about automating and making more efficient the route from completed thing into production. It starts you talking to the business and about how the requirements process works, and how you get better requirements that are able to feed into a process that you can automate. There's some good stuff. The approach that I recommend is pretty complete. It's not quite. It's more constrained than agile processes usually are, to my mind. So as I said earlier on, there's some stuff that I would rule out, and there are ways that of working that I would quite strongly recommend. One of those is using techniques like BDD, thinking about the problem from the point of view user, trying to create an executable specification from the behavior of the system. So you can kind of start doing all of those things. The big cost in big organizations usually is manual testing. So you want to eliminate all manual regression testing and use manual testing for exploration, just for new stuff, not for regression testing. And you want to automate that. And there are some good techniques. Again, check out my video channel, my YouTube channel. So there are some techniques for doing that kind of thing. And there's a bunch of steps. I am going to do a sales pitch. I have some online training courses that are intended to help people get started and do some of this stuff, and go into this in a lot more depth than we can in an hour.
Yeah.
So check those out if anybody's interested.
Excellent. Dave, thank you so much for your time and for this conversation. It was super interesting. I'm sure we could continue like this for at least a couple of hours. Thank you so much, and hope to talk again soon.
It was a pleasure. Thank you very much for inviting me. Thank you.